In order to maintain my mathematician card, I need to present some actual proofs from time to time. Proof in mathematics is often misunderstood and frequently misused. While a proven statement is reliably true, nobody bothers to prove a statement they don't already believe to be true. The true value of proof comes from the 3 R's. A good proof reviews what we know, reveals new insights, and raises new questions. Now, the last is mostly important if you're doing original research, and since you can't be taught originality, we'll emphasize the first 2 aspects about how proof reviews and reveals. For example, let's prove this relationship that the complement of A intersect B is the union of A complement with B complement. And note that this is a statement about 2 sets, the set A intersect B complement and the set A complement union B complement. And it says that the 2 sets are equal. Now, since a set is a collection of elements, this means that the 2 sets have to have the same elements. Anything in one set has to be in the other set. So a good starting point in a proof is you can assume anything you want as long as you make it explicit. So let's consider some element of the complement of A intersect B. Now remember, the set X complement includes all elements that are not in X. Since this element is in the complement of A intersect B, it's not in A intersect B. And in order to be in A intersect B, an element must be in A and also in B. So if an element is not in A intersect B, then it's either not in A or not in B. But the set consisting of things in either X or Y is the union of the 2 sets. And so this element must be in the union of the complements. And so that means everything in the complement of the intersection has to be in the union of the complements. Now let's consider something that's in the union of the complements. So since that's a union, an element in this set is either in A complement or in B complement. If it's in A complement, then it can't be in A intersect B. And so it must be in the complement of the intersection. Likewise, if it's in B complement, it will also be in the complement of the intersection. And so everything in the union of the complements will also be in the complement of the intersection. So anything that's in the complement of the intersection will also be in the union of the complements, and anything that's in the union of the complements will also be in the complement of the intersection. And so the 2 sets have the same elements, giving us that equality. Note that our proof of the complement of the intersection is the union of the complements required us to review the meaning of set complement, intersection, and union. It also revealed an important idea. If we're in a set, we're also in the union of that set with any other set. This insight will be useful later on, so you should remember it. And the best way to remember it is to use it as often as you can, for example, by doing another proof. So what about the complement of the union? So as before, let's consider an element of the complement of the union. This is something that's not in the union. Now, to be in the union, you can either be in A or you can be in B. So in order to be in the complement, both of these have to be untrue. You're not in A and you're also not in B. So this means you're in A complement as well as B complement, and so you're in the intersection of the complements. So suppose you're in the intersection of the complements. This means you're not in A, and also you're not in B. So you can't be in the union because you're not in either of the two sets, which means that you must be in the complement. And so everything in the complement of the union is in the intersection of the complements, and everything that's in the intersection of the complements is also in the complement of the union. And so the complement of the union is the intersection of the complements. And put together, our results give us De Morgan's laws. If A and B are sets, then the complement of the intersection is a union of the complements, and the complement of the union is the intersection of the complements.